Um, Hello everyone, and I welcome all the attendees, and I hope everyone can hear me. Am I audible?
Yes,
Uh,
we can hear you, Dr. Saab.
okay, thank you. That's good. Okay, so just to confirm, Madasa, my slide is visible to you? The first slide.
Yes, it's
Okay,
visible, sir.
okay, okay. Thank you. Okay. First of all the attendees and all the people who are listening to me, welcome to the BIM for tunnels and underground infrastructure. Okay. I'm Dr. Abubakar Sharafat, and currently I am engaged with the NUST. I'm an assistant professor there. So before going to move further, so here is my brief introduction. I have more specialization related to the building information modeling, automation and construction, construction management, and tunnel construction and management. So I have a PhD degree in civil engineering with a major in construction engineering and management. And my key life points to go through, I was graduated from UET, then I have worked in NESPAC, then I did my PhD from a foreign university and my master's as well. Now I'm serving in NUST as assistant professor, and I have been represented at the Asian Development Bank for a small assignment, and also I have been involved for the United Nations Development Program, and also for some other organization which I have been shown as Flash. Okay, so let's move to a topic because we have 1 hour. So I hope in 1 hour, of course, we can just have the brief overview of this content as flashed. Why BIM for tunnels and underground infrastructure. And then we discuss about the digital design and building and operation of underground space, the tunnel and powerhouse example. And then we discuss about the BIM and damage prevention of underground utilities. And then importance relation to Pakistan. I just made a one slide because it can be more about discussion, as I hope most of people having a from academia or industry, or you have a knowledge of how BIM is important for Pakistan, and also there are other speakers who are going to discuss about the importance of Pakistan. Okay, so I just go through just one slide in the end. So okay, first of all, I'm just going to skip a lot of things which are more like a theory or the things which almost most of people who know about the BIM, and there are other speakers who have been in this BIM week for Pakistan, and they have been discussing all this stuff. So, okay. So first of all, the first thing is what is BIM? Okay. So to be for me to make it more precise and simple, technique to manage and visualize the process of construction site. So their definition for me is more in how we are going to use BIM applications. We're talking BIM, and you can see the historical timeline of the BIM development. As you can see that in 1982 we have the first like 2D CAD drawing. Okay, and then there's a development over the years, and then we have the Revit in 2000. Okay, in 2000 we have the Revit, and there was a work start on the 3D modeling stuff. But now today we have a lot of BIM softwares. We have different type of AutoCAD or different other vendors software available for the development of information modeling and data informatics related to the construction engineering. Okay, so moving forward further, what are the challenges of a construction industry? Basically, traditional industry issues. As we know that the construction industry is totally different from the manufacturing industry. As you can know that the manufacturing industries have already been automated, and there's a lot of information. Let's take an example of any shoe factory or any automobile factory. You know, there's like a section for everything, and their product is coming, and it has several parts. The several parts are constructed in a specific domain, and then all these are like joined together to have one product. However, it's not for the construction industry. So basically, it's a totally different from the manufacturing industry. We are developing a product, but at the end, we are managing many things together. Okay, so thinking that, and also what are the issues we are having for the construction industry is that there is a lot of strategic management thinking. Okay, and there is a change in management all over the world in every industry. But still, we have lack of standardization, and of course the construction is more complex, what I talk about. And the other thing which is all over the world is urbanization. The cities are expanding, and there's a lot of construction is going on. And one more important thing, which is also one of the global goals, also sustainable development goals of UN 2030 agenda, limited natural resources, that the resources available to us are limited. So how we are going to, how the BIM is helping the construction industry, and what are the challenges we are going to have it, okay? So when we talk about the BIM in relation with the construction industry, now, as you know that the BIM has been, when we talk about being an architecture, from the architecture point of view, from the architectural engineering point of view, or only from the building point of view, the BIM has been established or matured very much in the building industry. You know, there are a lot of BIM projects which has been executed successfully, and there are a lot of success stories for the BIM projects. But when we talk about the BIM in relation with the civil engineering or infrastructure projects, such as the structures, or like we talk about the power plants, we talk about the railway, bridges, roads, and tunnels, there is still a development is going on, and there's still a lot of standardization issues. There's still a lot of software issues. Okay, so if you look at from the civil engineering point of view, so we just look from the architecture point of view, the BIM is very established and matured. So now we look at this. Now the BIM is becoming very specific for the every field. Now it has been applied recently in the railway projects and bridges, and now we are moving towards calling them a SIM, or civil information modeling. And then there's like a concept of railway information modeling. We can call it RIM. Okay. Similarly, the concept for tunnel information modeling is called a TIM. Okay. So I have been working in this domain for tunnel information modeling, and I have been one of the founders for developing the standards in IFC, for proposing the standards and working. I'm currently working to develop the BIM for the tunneling projects. As you know that the currently right now there's not, we cannot say there's one specific software which is dedicated or which is very much specific that we can design the tunnels very easily. Maybe from the attendees, there are someone who is a tunnel design or related to tunneling engineering. You know that it's a very complex process. Okay, so I'm going to discuss in the later slide. So this is what now the BIM is not just for the buildings. Okay, now it is applicable to all the construction sectors. So being civil engineers, okay, when we talk about the BIM only for the architecture, so the architectural engineers are very good and also equipped with very good with the graphics and with these softwares. Being a civil engineer, I believe that it's not only about the visualization, it's more about the numbers. Okay, for the architects, maybe visualization is good enough. For us, it's always about the numbers. So we have to develop, when we are going to develop a BIM model, it should be more about the number. Number means quantities, scheduling, and visualization is always there. And of course, there are other aspects like a design aspects and everything there. Okay, so this is very famous figure about the process of BIM. And if you just start the basics of BIM, so there's of course the planning, design, build, and operate. So I'm not going in detail, but of course for a civil engineer to integrate the analysis and the documentation is very important with a BIM. Okay, and of course operation and maintenance is very important being a civil engineers. When we talk about the characterization of BIM, normally it started with 3D, then we have the 4D and 5D, and from 6D, 7D, 8D, to me, it looked like it depends upon the project type. For me, maybe the 6D can be the VR or AR, depending upon yourself, or it can be sustainability, or it can be anything, or safety, or maybe some structural analysis, or you can say the technical analysis related to the civil engineering. So this is depends upon the nature of the project. Okay, so this is the characterization of BIM for civil engineering. Let's talk about the road information modeling. Now, there's a lot of effort has been put for the road information modeling, in which all the information of the project and the quantities from the design to the execution stages are monitored through BIM. And then there's civil information modeling, as I have already discussed, in which there are a lot more aspects which are covered. And when we talk about BIM as a civil engineers, so BIM is not only about the 3D design, okay? BIM is not only about we develop something in a Revit, or we can develop something in the AutoCAD or any other vendor software and think, oh, we have developed a BIM, okay? For the civil engineers, managing a site using the BIM is more important. And one more important thing, having a knowledge and a degree of master's related to automation in construction, the key for the BIM is one part is the management and the other part is automating the construction industry. Let's assume we have a 3D model of BIM, and now if you want to manage a site remotely, there can be a CCTV where all this information is coming. And maybe there are a lot of other software and sensors through which you can even handle your machinery or the equipment, okay? Or you can handle the productivity of your personnel. So this all information or the data is coming, okay? So for me, if I think of BIM, an Excel file can also be BIM for you if you can manage it a good way for a civil engineer. So BIM is not only visualization. This is what I'm focusing a lot. Of course, this is the first step, but this is not all BIM. Okay, if you're managing as a civil engineer anything remotely, it means that it's becoming a part of BIM also from the automation point of view. Okay, so let's talk about now, having a general overview and introduction. Now I'm going to more detail, which is my specialization or my more focus. Of course, I'm also engaged with other BIM related to buildings, structures, and other stuff, but I'm very focused on the tunnel and underground infrastructure. Okay, so in the 20th century, the tunneling has revolutionized the construction industry. Okay, it has now become an integral part of civil infrastructure projects. You can see that in transportation, there are a lot of tunnels all over the world. Of course, the Pakistan, the tunneling is just in the beginning of the beginning era of the tunneling projects. We have some tunnels like we have the Lawari tunnel, the Kohad tunnel, and then we have some hydropower tunnels and tunnels in the some dams. But now you see there are a lot of good road tunnels which are developing in Swat motorway. There are very good tunnels which are constructed recently, and even Hazara motorway, we have very good tunnels constructed. So the tunneling is becoming it's all over the world because now it's one of the most important aspects of civil engineering. So they provide you transportation, they are related to the energy, they are providing you the water supply, then they are using for the urban utility. Okay, of course, in Pakistan also in the modern housing societies, you are having all the utilities are coming to your homes underground. And then of course there are a lot of military facilities and also the nuclear facilities and the dams. All the modern hydropower projects, they're also related to the somehow the tunnels and underground infrastructure. And then there are a lot of flood control projects all over the world. When you consider about tunneling, so tunneling is not like a simple project because you're dealing with the environment which is underground and which is unknown normally, and you can expect anything. And so there are different tunneling methods depending upon the project type and also the feasibility, rock conditions, and also the economic aspect. Okay, so when you talk about the BIM is continuously developing for the civil industry. So its potential, it has also a lot of potential for the tunneling industry. Okay, so we are going to discuss that today in detail. Okay, so when we talk about these civil infrastructure, different civil infrastructure categories, so you can know about the bridges, road, tunnel, airport, we already discussed. When we talk about, so it will be more focused about the category number 4, which is the tunnels, which is, it is just put like more in a transportation infrastructure in that part. So basically, when we talk about the application of BIM in civil infrastructure, so the vendors which are providing us a different type of software tools in which we can develop the BIM for any internal infrastructure and also for the civil infrastructure. Generally, these are more famous ones. Of course, there are a lot of other which are developed like a locally or from special organization for a special purpose. We have like Autodesk, very famous. Then we have the Bentley. Bentley is a very good one, but it's mostly paid. And then we have the CSI, which is SAP includes. Then we have the Tekla, and then we have a Graphisoft and Visco and Forum 8. Okay, so they are different, but of course, Autodesk and Bentley are the one who are leading the BIM industry right now. Okay, so when you talk about the underground space project, it's similar like other project. There's a triangle for the projects. You know that we should minimize the cost, we should have the required quality, and it should be on time. If you change in one of the constraints in any construction project, especially in a tunneling project, it can cause trouble. Like, okay, in maybe in above ground projects, a road project, and now uh, you just with a minimum cost, maybe you reduce a cost so much, or maybe uh, before on time, or you reduce the time, or you're playing a lot with the time. You reduce the quality for a road project. Maybe the road is broken, or you have a lot of wear and tear. Instead of life is 10 years, you can have in 4 or 5 years. Of course, it's a problem for the transportation, but maybe it's not that hazardous. But in case of a tunneling project, if you reduce the quality, it means the tunnel is going to collapse. And when minimizing the cost of a tunneling project, very careful about the required quality and also on time. And I've already discussed about it, talk about the time of a tunneling industry. There are a lot of things because now you are underground and there's a lot of information which was hidden from you or which was unavailable during the feasibility or the design stage. So if you reduce or you try to be quick or you try to reduce the quality, if the tunnel collapse, it can be very fatal. It can cost a lot of lives. Or if the portal fails, it can be very hazardous. So in underground space, this triangle is very important. As a project manager, as a BIM manager, you have to consider and you have to manage 3 constraints together. So keeping balance everything. And an underground space, there's a factual environment. When we talk about the factual environment includes a lot of data and a lot of information. And then there's a lot of risk management. When we talk about the risk management, it includes all your time schedules, your risk related to the geotechnical, risk related to the management side. So risk related to the cost, if the project cost is overrun or something. And then there's a social environment, because when you are of course every civil engineering project has a social environment. And in a tunneling project, there are a lot of stakeholders like other projects, but in tunneling, maybe there are different type of engineers we're working together, and there are several stakeholders always. It's not only the 3 stakeholders which are in general, like a client, contractor, and consultant normally, or subcontractor something. Maybe you can have a different fields of engineer working together, like a blasting, like we talk about the other thinking from the blasting engineering, there can be mechanical engineers working together, and there's a different domain, that there are different stakeholders. And of course, the community is always a big stakeholder in every project. And a tunneling project, the communities are always a big stakeholder. Okay, So when you talk about the underground construction, it's a continuous decision-making process. It's not like this that you design a project, oh, that's it, and there will be minimal changes. Maybe there was an underground fault, or there was an underground environment, or you are unable to detect from the above ground. Sometimes your tunnels are like 500 to 600 meters deep. You are unable to assess its condition by drilling only the boreholes, and also the limitations like it's almost impossible to drill a borehole like a 500 to 600 meter during the feasibility stage. And of course, there are the characters of tunneling projects, and then these characters generate a lot of data. Okay, and this data is having a lot of shows a lot of information, and this information gives you the know-how of this, and then you develop a decision. Sometimes in a tunneling project, there's 100% change in design on site, and the decision have to make based on the information you are getting right now. Okay, so the information is very important, and to build an as-built information is very important from the facility management point of view. Okay, very good. So let's move further. Okay, when we talk about the objective of BIM in underground space, of course, any project, and especially in a tunneling project, we want to have a continuous, lossless, and machine-readable data flow. This is the basic objective of any tunneling project in respect of the BIM. Okay. Of course, there's the initiation and then the design. Then during construction, we are having a lot of information, and when we are handing over, still we are closure the project, and there's a lot of information which is coming sometimes from the client and from the contractor, and now you're handing over the project, and then there's the end of the life of a project. Generally, underground projects are very much costly and they are very high budget projects. So the life of the underground projects are generally range from um, okay, the minimum is like can be any time from 1 to 2 to 5 years, but it can last up to 100 years. Okay, we have tunneling, we have the tunnels still built in Pakistan even during the era of the British era, and still they are working. Let's talk about the Kojak tunnel also, and we talk about one of the recent project like an Elam Jhelum hydroelectric power project in which they developed the hydropower tunnels. Its life is something around 80 to 90 years. So the end of the life of a project is very important, because in the middle of a project, like in the middle of a project, now you have a problem with the project. Maybe all the people who work on the project are not available, or maybe 60 years. So it's a long span of time. So how to dig out this information to increase the life of that project? Okay. So when we talk about the data, okay, so we are having a lot of information. Okay, so there's a lot of information which is coming. We have the data from the design drawings. Okay, then we have the scheduling data. Then of course, if you are doing, there's a lot of information which is coming from the tunneling method. If you are going with a tunnel boring machines or TBM, so there's a lot of information which is coming through that. Or if you are going with a drill and blasting, still there's a lot of information related to the charging and the vibrations and the community or the housing or any society living to that or any infrastructure to that. And then we have the design drawings, and then we have the geological information, which is a critical part in an tunneling project. And generally this information is coming when you are excavating through. Okay, so we have the journal geological information, but it might not be that accurate during the feasibility or the design stage. And then we have the productivity and daily progress in, because now so you can monitor when you're going to complete your project. Okay, so in an underground space, we it's like a jigsaw puzzle. Okay, we have a lot of information, or no, we have a lot of software with which we can. There are a lot of like a software in which we can do the simulation of tunnel drive. We can run the structure analysis, and then we have the LMS-based tendering, and we can talk about the model-based operation and monitoring. Now there's a digital twin for all the trades, or we are integrating the project with the tunnels. but there are different type of software which are available for the tunneling, but it's really hard still in the current environment even, to really integrate this jigsaw puzzle because it's a lot of information. And there are IFC for the tunnel standard also under the development. So, and also to make a, if I'm talking about only the underground space means everything, even because I'm going to discuss about the underground utilities as well. So even for the underground utilities, maybe if you're talking about in Pakistan, we did not have a very good mapping of the underground utilities. We don't know where our gas pipelines are sometimes. And we don't know, even we don't have any heritage mapping of the old era. So there's a lot of information in underground which is hidden for us before any construction project. Okay, so if you look at this, these are like just like a sample for you, like how complex any underground project can be. On your left side, this is like a underground hydropower station. Okay, example of a underground power station. You see there are a lot of complex tunnels, and then there's like shop. Then you have the powerhouse. Then you have the transformer hall, and there's the crane, and on the top there's like a dam, and the other side you see just like information of the project data related to the dam site. Okay, and so there's, and the tunnel, so there's a lot of information in this project, and you can see there's the boreholes data that is plotted, and then there's the geology and underground information. Okay, so this is just like example showing you the 3D model of some of the projects, famous projects. Okay, so as I told you that the process is totally different in underground space, okay? And it becomes more complicated when you talk about the unfavorable geological conditions, okay? So when you talk about the tunneling engineering, it requires a multidisciplinary knowledge and data sharing from the different domains of a civil engineering, okay? So maybe we can, in one project, we can adopt like a 2 or 3 different tunnel construction methods. Okay, so when we talk, so there are different tunnel construction methods, such as we can have like a cut and cover tunneling construction method, which are generally used in Pakistan a lot for developing underground passes or sub passes. It's very good example is the canal road in Lahore. Okay, in which they cut and cover. And then we have the drill and blasting, which is still one of the most adopted tunneling method, and in which you put the blasting material and you excavate through the blasting. And then there's the TBM, which is very good, and in which there will be a lot of benefit for the BIM. And the BIM is adopted, and they are already adopting BIM. Then the jog bulk method, and there's the NEDM method. So even for the constructing of one tunnel, maybe a 2 or 3 or even the 4 methods can be combined together. So that makes a tunneling or underground space a very complex, or tunneling engineering a very complex engineering. So I give you one example. Okay, let's talk about the drill and blasting method. Okay, so maybe we can have like a drilling party which comes, and then they charge the hole with explosive, and then they blast it, and then comes a mucking party who just take all this muck out. Then there's like a scaling, and then they do the mapping of the geological features. And then the surveyors come, they look around the profile of the tunnel and the alignment. And then there comes the engineers who are going to the related to the rock support, and there's a lot of auxiliary things like watering, lightning, and the service lanes extensions. Okay, now come to the topic for the tunnel. If you want to go towards the tunnel information modeling, or information modeling of tunnel based on BIM, so maybe we have to based on a multi-model approach. Okay, in a multi-model approach, there are a different tunnel model which are combined together for different purpose. Okay, because and it's also like a cyclic process, so you cannot like supersede one process and do the other process once. So it's like a very cyclic process, and everything is so much interconnected. Okay, so maybe we can have like a blasting excavation model as separate, then we can have a surface and ground model, And if you want to go and visualization in VR, we can have a separate model. Then we talk about the geological rock model and rock support model and a concrete lining. Okay. And also currently right now, we don't have any one specific, like Revit is very good right now for having all these, storing all the information of the building projects, maybe also all small infrastructure projects, and maybe Civil 3D is very good for the road projects and other things. Okay. And there are some other like projects we can, some other modules of Revit, modules of Autodesk, which are good just for the preliminary design stage of a tunnel, infra works, such as, so you can just design the basic things, but it's not about, no, the BIM is not only about the basic things. You have to go in very detail. So you have to establish different type of models now for that. So we can go for the multi-model based approach in which the different models can be established in the different softwares, and then they can be integrated together in a different, like for the alignment, maybe the alignment of tunnel, it's where, or the borehole data, maybe it's very good if we can use the Civil 3D, but maybe for the quantity estimation and for visualization of the quantities of the rock support, maybe the Revit is a good tool. And for the face mapping, maybe the other such as like 2D AutoCAD is good enough. And then we can have the scheduling through Primavera, or even we can do in Dynamo. Through Dynamo, we can import in the Navisworks, or we can directly do in Navisworks. So, and there's a lot of information which is always in a 2D drawings, and they're the ASTM standard as well. So we can go for the multi-model approach, okay? So, and we can establish different models in which is shared in using the interoperability and IFC standards. Okay, so this is like a tunnel information model container, or we can call it a multi-model container. So we can have a topographic map, topographic model, which shows you all the domains. Then you can have the borehole model, and then there can be a blasting model, a geological model, a rock support model, and a concrete lining, which include the reinforcement detail and everything. And there can be one model which combine all this information. Like other some of the buildings, there's a lot of information which is hidden behind the other layers. Okay, so the final product of a tunnel, you can just see a concrete line, but there's a lot of information which is hidden behind. When we talk about the intelligent models, so when we are going to have the surface terrain model or ground model, so it should include all the information now. Okay, so it should mark all your water bodies, it should mark your fault lines and your engineering geology knowledge, such as your dip angles, dips, and all the information for the dip direction and the coordinate of the boreholes and the inclination of the boreholes. So this information is really important now from the feasibility stage. So if we have a very good 3D intelligent model related to that, it can help the designers to decide the route and design for the tunnel. Then we go to the blasting and excavation model. So we should know everything should be documented and in a 3D way, and we should know basically the rock quality and the diameter of the holes and every detail of the blasting or the excavation. Rock blasting should be included in that. Then we talk about the geological model. So when you talk about the geological model, so it should include all the properties of the rock we are encountering. Okay, so let's assume we have a rock, so it should have its, what is the joint set number, what is its infilling, what are the bedding planes, and how these are oriented. And there's also a lot of monitoring, in every project, especially underground projects. You're always worried about the convergence, that how much convergence we are happening. So you can have also the convergence station. So you need to know what type of information and how you're going to collect this information. And then we go to the rock support at the design. Okay, during the design stage, it's not only the shape of a tunnel we see. Okay, and in a tunneling project, there's a lot of information which is hidden behind. When you talk about the rock tunnels construction, there's the rock support. Okay, rock support includes the rock bolts, we may have the wire mesh, we may have the lattice girders, and then there can be a thin membrane for if there is a water seepage, and then there's a lot of like utility lines such as the water supply or the compressed air during the construction process, and then there's the lightning. And during the concrete lining, it can be without reinforcement or it can be with the reinforcement. So it can be like a lot of information which is hidden behind. So the tunnel we see is a very fine, and we look around and it looks like a very clean thing, but there's a lot of information which is hidden behind. And we need to have all this information documented in our BIM model. Okay, so when you talk about the developing any tunnel, okay, so we don't have any direct right now any direct software in which we can just go and select the shape. You know that there are different shapes of a tunnel. You can have a horseshoe, it can be mouth profile, it can be a circular tunnel, or it can be a modified horseshoe type. So basically, if you want to do it, so you have to define the elements of what the tunnels consist of. You can have a spring lines, then you have the roof, you have the shoulder, and you have floor. So you can do it in a Civil 3D right now. We are, me and my research team in collaboration with some of the foreign university, we're trying to develop software in which it will be similar for that like how it's become very easy now using a Revit, that you can construct a building. You just select an element of that thing and you can just like give the basics input parameter and it is there. Okay, for the tunnel it is not yet there. We're talking about the detailed design. So you can develop using some of the other like other tools which come as accessory tools, or you can use the Dynamo as well. And also there's still a lot of problems we are going to when you're going to use the BIM software for the tunneling. Okay, like I'm just giving you one example. It's very hard because the tunnel geometry is curved, and putting the rock support perpendicular or normal to the plane. So maybe you need to make your own. There's no families even if you go to a Revit, so you have to develop your own families. And now you have to, if you're going to place a perpendicular, so generally to that curve, it's really hard to place that family. So maybe you have to develop your own codes in a Dynamo for that purpose. So it is just one of the example. So right now the BIM software for the tunneling industries are not very user friendly. So maybe you have to have a lot of information, or you have to have a lot of hands on the several different software, so you can just enter in that BIM for the tunneling things. Okay, so when we talk about the level of development, or before it was used as the LOD or level of definition or level of, but now we are basically, before it was more was a depth of information, or you can say it before. If you can look at this, if you go behind in 2000 era or even after that, let's take an example of the Need for Speed in Need for Speed 2 or other games. You can see at that moment there was a lot of computational restriction because we don't have a good computations at that time, and the graphics, and there were limitation. So this concept was used to give you the depth of information, which you call that, or LOD at that moment, was more about the level of definition in which you define the products or the things which are close to your camera or in a game. Remember, previously in the game, so you have the information which was very close to you was very clear, and the information which was very far from you were like a blurred, or like the graphics were really, or the pixels were very like wide. So just to reduce the computation, but now we have a very good computations, but still is very important for regarding the level of development, that what information you need at what time of project. Let's assume you develop a detailed design, even the pre-designed model. As a pre-designed model, you just develop a detailed design, and maybe the project is not going to happen. So at the feasibility stage, there we call it as a level of development 1, in which we just go for the pre-design model, and we just give the basics and the feasibility and location of tunnels. So this is just like a different level of development we have to define for that tunneling projects. Okay, so let's take a case study. Okay, so this is a real data which is taken from the real project. Okay, so you can see the first on the left corner, the first drawing show you the plan and profile of a tunneling project. Okay, so it's a twin tunneling project with two tunnels running through with the and we have the profile of that, and then we have the design drawings in the left corner in the left bottom corner, and then on the right corner we having the information which is coming during the tunneling, and this is called the geological information which is coming through that, and the bottom we have the planned schedule. Okay, so this is the information which we have during the design stage. So considering that, and we have all the surface different terrain, so we developed the terrain model for that project, and then we have these twin tunnels. Of course, these tunnels are like more than 300 to 400 meters beneath the surface of the terrain. And of course, when you talk about the above ground information, there can be the rivers, there can be the falls, and there can be the small nala, or you can have a lot of springs, or there can be what type of rocks there are. So you mark all this information, because let's assume, take an example. If you are tunneling any other river, so maybe at that portion of the tunnel which is just behind or just bottom beneath the river, or which is along the splay of the rock bed, or the along the bedding joints of which are angled to the river, you might have a lot of water in rush. So this information is very helpful to giving you information about the underground, how your tunnels behave related to the above ground, or if you have any fault, maybe that fault is also linked to that tunnel. So maybe you know that at that portion how we can design it, and the BIM can give you all this information together in a one model. And then when you talk about this, so we have a lot of basic geological information models, but now when we talk about this, what I told you in the beginning, that it's not only about, we're talking about the visualization. As a civil engineer, we are more worried about the numbers, and we are also very much worried about how we are going to having the like all the analysis we run. So based on these analysis, and also we know which part needs what type of rock support and what type of excavation method and different type of information. And then we develop this type of model to calculate the quantities and all this information. Okay, let's give you an example. On the right, on the left side, this is like a stereographic map which shows you what type of failures can be in a tunnel, and how, and based on this information you can design a rock support, or your tunneling method you can modify rock support. On the right side, this is like a convergence 3D visualization of the convergence. Okay, that by looking at this model very clearly, you see, oh, the red. So at the red portion we're having a lot of convergence, so maybe you can just go and do some treatment at that portion. But if you give all this data which is coming in a, which is coming just like what I can say, which is coming through the manual data, maybe it's very hard to visualize. You have to go through every data, and then you have to compare and come back. Or maybe you can just develop like the 2D graphs, but this you give you the better visualization that how much convergence you are going to have. And then there are several other stability and technical analysis. You have to be incorporate all these things. So when we talk about the application now, the BIM, so we can have the 3D, or like we can have the scheduling, we can have the process simulation, and we can have the render images which are very close to the project. And then we can do the technical analysis, and based on all build information, we can do the design review, or we can calculate the quantities. Okay, so these are the different applications of this. Okay, so these are some videos, but of course, we are sharing through the WebEx event, so I think it might not play in that enough browser. So we can evaluate how the let's take the, so doing one of the quantitative, like a qualitative and quantitative study of evolution of on this case study, that this was more like academic case study in which we're trying to establish that how BIM is effective for the tunneling industry. So you can see that they are like a schedule concept was 39, which was actual happened in a project was 48. So actual everything happened in a project was that 48 was encountered and they were not detected before. So this is like a evaluation of the different things. So we can have like a 3D evaluations, 3D realization. We can have the automated quantity takeoff. We can have the more detailed information of the material. We can do the design change in one aspect and it automatically changes the other aspect. I remember when I used to work as a tunnel design engineer with NESPARK. So at that moment we have the 2D drawings with so if we change one if we change the plan and profile, then we have to go to all these drawings and then we have to correct them as well. And then we have to do the QA/QC is very hard job in a tunneling project. Actually, in civil part, it's really hard, but in tunneling, it's really hard. So it automated, and you can have the phase planning with the design coordination, which becomes automated, and the data sharing and the model based analysis also can be integrated. Okay. So by using this qualitative evaluation of BIM in a tunneling industry, it looks very useful. And oh, I attended one of the conferences in, I think it was in Korea, South Korea, in one of the cities on the East Coast, that they have developed a BIM and they were applying at that project that moment and they showcase it. So at that moment they were trying to get all the information which is happening inside the tunnel to get all this information out on the surface. Okay, so the BIM is not only related to the data or visualization, it's also related to automating the construction industry. Okay, this is also an underground powerhouse. So you can have it's all the geological information. It is very helpful deciding different type of stuff, or maybe in the future of the facility management. On the right side, there this shows you how you're going to excavate it. So this can be the excavation model. Every box should be excavated like one by one. And then this is like the structural model, which is built for the inside powerhouse. So you can see column beams, and then you can do the structural analysis of these column and beams. Okay, so as it is like a 1 hour sessions, but still I'm just going to go through very quickly about the BIM and the damage prevention of underground utilities. My basic goal or my basic purpose always that I believe that how practical the BIM is. It's not only that, oh, we just developed some model on the Revit, and what's its application now? Okay, so we all the stakeholders or everyone who is linked to the BIM industry, that we should make it very practical, and that should drive the construction industry to adopt in the realistic field. Okay. So let's take an example, like the underground utility is a big trouble all over the world, and there are like 50,000 utility strikes every year in only in the United States. Okay, because they have a lot of underground utilities. There are a lot of big projects which have like a big utility damage accidents. This was one of that one in North Carolina, in which 8-inch steel gas pipeline was stuck and it was fire all over. And then also in November 2010, there was an also very big explosion and at least killing 2 and 3 people. And when a bulldozer stuck as a gas pipeline. Okay. So going through very quickly, so there can be a different technologies from which we can get the data, we can process it, and then we can model this information and we can use it during the excavation of that project. Okay. So again, in this I'm quickly going through the case study. Okay. For that, to develop the above surface model, we have used the drones. Okay, this is you can use a drone in which to collect the different images, and then using different softwares, you can develop the 3D models. So these are 3D models which are geo-referenced using the 3-point cloud data using the different type of softwares, of course. And then, of course, there's a UAV. Okay, when the 3D model is developed, so this is a system overview. This is like a more details, but of course you can go it and just go through it. Okay. Okay, so once we have all this information, so we can get the underground info, we get the above information from the we can use a drone or laser scanner, the different type of the latest technologies from the underground. We can use, these are a lot of, like, let's assume we don't know where the underground utilities are. No, we are going to run this project. In developed countries, it's a big issue that if you do any utility strike, maybe you could get a penalty more than the cost of a project or more than the profit you're going from the project. So you can use the GPR to get the underground information. And now once you have the underground information, now you can develop the 3D models of that. Okay. So this is how the information is collected, and then you can develop the underground utilities. Okay. So this is just one of the examples when these underground utilities are mapped. Okay, this is something. So this is like a practical implementation, which this is one of the underground installation of new sewer line for the water treatment in South Korea. So there was a new proposed sewer line, but of course the old line was there, but there was no mapping of it. So using the BIM, so this is new. You can see the trench. So this trench is a new model, which is going to be along the road for the new pipeline. And but the old pipelines are not modeled. So we acquired all this information of the underground, and we developed the 3D models of these. So we know that so we have also established the point cloud, and about each and every point we know that where our underground utilities are. And this was the real example. Now there are the latest modern, this is what I always concern about. So this is a real practical implementation of BIM. So now we have the modern excavators. These are called the machine guidance excavator or the machine control excavators. So these 3D models are input into these excavators. Okay, so the excavator operator knows. So this is a real screenshot of that, which is normally seen by the excavator operator. So this is a real time, on the left side, a real time image. So within a cabin, the excavator operator knows where my underground utility is. So he is able to avoid the utility strike. So this is what the practical implementation of BIM is. It's not, for civil engineers, visualization is one part, but it's not that you develop a very beautiful thing. But what's the practical implementation in a civil industry? So this is again another project in which you can see that, okay, in our excavator, we know that there was a pipe, and so this is the same different project and different terrain. And so you leave that space, and then you use the manual digging, or you can use the hand shovel to dig that utility. Again, this is one of the screenshot from that. Okay, so importance in relation to Pakistan, the BIM is now developing Pakistan, and we're more concerned about the tunnels. So there's a lot of hydropower projects which are currently under progress. If you talk about one of the biggest Nina hydropower project, I was privileged to work on there. So it was one of the world's second largest hydropower project in terms of the tunnelings. Okay, so then we are going to have a Dasu hydropower, in which there are also tunnels. In Bhasha, there's also some tunnels, and even in Mohammed Dam, there are the small tunnels for the, so, and all these hydropowers, most of them have the underground powerhouses. Okay, as earlier in my presentation, I discussed there are a lot of road tunnels which are going to be constructed in future, or which are just constructing right now. And now we're talking about the ML1, and if ML1 is going to extend to these mountainous areas of Pakistan, or there was a plan of developing a tunnel from Islamabad, developing a railway connection between Islamabad and Muzaffarabad. If it is going to happen, of course, it needs a lot of tunnels. And underground utilities are always a trouble, even in Pakistan. When you are going to the construction, there are a lot of underground utilities which are always unmapped, and it's really hard for the contractor to realize where he's going to do the digging and all this information. Okay, so concluding my today's session, I believe that the BIM help the project manager and stakeholders to have more control over tunneling and underground space project. And it is really important, and BIM can be really beneficial for the tunneling and underground space industry. And actually, because these are the things which includes a lot of information which is hidden, and it has a lot of potential to enhance the construction management, risk assessment, and decision making for the design and construction phase. And the integration of BIM and the technical analysis can facilitate the project managers, engineers, and stakeholders for the progressive decision making. So I hope I try my best to give you the basic knowledge of the tunneling related to BIM, BIM related to tunneling, or the BIM industry related to tunneling, infrastructure or underground space projects. I hope it will be very good, and it was very informative, and maybe a really different domain as a BIM engineers to know about it. So I hope you learned a lot, and it was really pleasure to speaking to all of you. So thank you from your side, from my side. And if you have any questions or you want to add something, because one more thing, when I talk about the BIM, so I have a PhD degree which is related to the BIM, but I still believe that no one can be the expert in BIM right now today in the contemporary world. So maybe from your side, if you want to add on something and you want to increase my knowledge, you're also welcome, or you want to have some discussion, the platform is open to anyone.
Thank you so much, Dr. Abubakar, for such a wonderful presentation. I think you have covered the whole topic. So we have a couple of questions here with us. So uh, Mr. Fazal Wahab is asking, like, after digging of tunnel by any means, the portion which is not strengthened yet by rock bolts, shotcreting and concrete lining, there is minor but continuous rock movement which is in millimeters per day. Can one using
Yeah.
BIM tools read and record such data? Either we have to use a scan to BIM, LiDAR scanning. Uh, can you answer this, please?
Oh, okay, very good. So this is very good question. Fazle Wahab, that's a very good question. So let's discuss about it. So once the tunnel is established, of course, if you have the convergence stations, if you know that, okay, LiDAR is very good. Okay, this is very good. If you have the LiDAR scanner, you can go and scan every day and coming back. But of course, if the tunnel is currently operational, and it can be in two parts, but I understand from your question, it can be during the construction or it can be after the construction. If it is happening during the construction, the LiDAR can be a very good option. You can just go scan and compare using different, the point cloud data, the yesterday and today's, the difference between that thing. The other thing is this, even during construction, maybe you can have the convergence stations, okay? So I have shown you in slide in which they have the convergence data. So basically, we have done this, but we use our own Dynamo codes to develop these things. So all the information which is coming, you can just put it there and you record the day wise. I show you that the different, like it was a colorful figure in which we have this different type of monitoring, like there's like every day it shows you how much convergence or which part has. Oh, okay, this figure, okay, next figure. So this figure, okay, in this figure, if the tunnel is operational or even during construction, so this is the chart is showing you the maximum convergence till now from the construction, okay, when it is constructed and it was like fully supported, okay. So you can see that the data is coming every day. It can be automated coming out if you have a good sensor or something, or even if it is manually coming, you can start plotting it, okay, you in an Excel file, and then you can integrate to the BIM model. But of course, right now there's not any tool which is developed directly in a BIM software. This is what we are working on. So maybe if we have in future, I don't know, but we are working on that. So you can do it. But in case we are having a running tunnel, or it is after post construction, like let's take example the Sawat motorway tunnel, then of course the problem, if you're going to do run the LiDAR scanning every day, it can be disruption to the traffic, or even if it's a hydropower tunnel, it's almost impossible. You cannot go inside to the hydropower tunnel. So it's a different in a hydropower tunnel. Normally we don't have the convergence once we fill the tunnels, but in case of road tunnel, so we can do the we can use the convergence stations, and we try to disrupt as much. Of course, we need to have uh, okay. what's expected data availability of the same or same. Uh, of course, we are, I don't know, because when even we are going to launch it, we are not sure about it, but maybe it still not have all the features because, the Rivet was launched in 2000 and it takes you like 20 years to get it. But if you want to be discuss about these things, and I hope Amir Gori or Fazle Wahab, you are related to the tunneling industry, and I have been a tunnel design engineer with an S-Park as well. So I know from a tunnel, it's very like, it's always like very good to see all these things. So maybe you can ask the moderator, yeah, or you can get my email ID and you can contact me directly. We can discuss in more detail.
Thank you so much, Dr. Abubakar, for answering the questions. We have another question. What softwares do we need from start of project, that is planning, designing till completion? So, Ikram Khan, let me answer you. According to BIM, we
Yeah, it
have
will
a
be very
couple
good.
of options for BIM workflows to implement BIM workflows. So, what I would suggest is from the feasibility stage, you can do the conceptual design. If you're doing on the building side, you can do like on format, and if you are like on the infrastructure side, you can do your conceptual design on InfraWorks, and then Civil 3D or Revit can design, and Nevis work can analyze and visualize as well. So we have also open source platforms and cloud applications, which you, for example, like BIM 360 and else. So you can use those applications and softwares as well for your BIM work implementation of BIM workflows. So thank you so much, Dr. Abubakar, for such a wonderful presentation. And